So in this problem, we're trying to find the limit of x sine of x minus x squared over 1 minus of x squared when x goes to 0. So they want us to use Taylor. This problem was already done before I did it using operator rule. It was very, very tedious calculations with high risk of doing mistakes in the derivatives because it gets very complicated. We had to use operator rule more than once, at least I believe 3 times or 4 times. In this case, the Taylor polynomials can be a wonderful tool. So the trick here is to use the fact that for a nice function f of x, okay, we can approximate by the first non-zero term. So something like x, coefficient here b, x minus a to the power n, where a is the center of the Taylor polynomial. And usually the a is given to you as the limit because you have x close to a. So you start with the first non-zero term, and that's the one you have here, the non-zero term, okay? So you have this kind of approximation, and that's really is a wonderful idea. So here, if we go, we have, what are the functions? We have x sine x minus x squared and 1 minus cosine x squared. So the focus will be on two functions, sine x and cosine x. So we know the Taylor series for sine x is x minus x cubed over 3 factorial x5 over 5 factorial, etc. And we know the domain is minus infinity plus infinity, so we have no problem. Okay, for any x, we have this series convergent, and the sum is sine x. And for cosine x, similarly, same idea. The radius of convergence is plus infinity, and this is 1 minus x squared over 2 factorial, x4 over 4 factorial, etc. So now we need to have cosine of x squared. So we have to plug in x squared. So we get x4, because it's x squared squared, plus x squared to the fourth, x8 over 4 factorial, etc. And now we need x sine of x, and that's x squared minus x4 over 3 factorial plus x6 over 5 factorial, etc. And now we have all the functions to generate what we want. So x sine x minus x squared will be minus x4 over 3 factorial plus x6 over 5 factorial, etc. While 1 minus cosine of x squared is going to be 1 minus 1 is 0, plus x4 over 2 factorial, x8 over 4 factorial, etc. So we keep only the first non-zero term. So we know that x sine x minus x squared is close to minus x4 over 3 factorial, and 1 minus cosine of x squared is close to x4 over 2 factorial. And this is, of course, when x is close to the center, which is 0. So now if we take the ratio, we see that x sine x minus x squared over 1 minus cosine of x squared is very close to minus x4 over 6, 3 factorial 6, x4 over 2, 2 factorial is equal to 2. Algebra will give us minus 2 over 6, which is minus 1/3. So you see when x is close to 0. So the limit, you are close to a number, so the limit is that number, minus x squared over 1 minus cosine of x squared when x goes to 0 is equal to minus 1/3.